So hello. So today we are going to discuss one question called as flood fill. Flood fill algorithm is also called as lead fill, and it is a very famous algorithm which is used in our computers. And if you go to the Wikipedia page of the flood fill is also called as lead fill, and we all have used this flood fill into our computers in MS Paint. So if we go to the MS Paint, we must have seen something like this, right? So if suppose this is the area, and if we click on let's say anything here, then the entire area is going to be filled with a new color. So we basically say that with a new color, this entire area is filled with a new color. So we say that it has been flooded with a new color. So this exactly is called as the flood fill algorithm. So even if you see it here, it started from here, goes down here, and so on, then returned back, and then it continued, and so on and so forth. So, exactly what is the prompt statement is, I'll try to explain that prompt statement. So, the prompt statement looks something like this. So, if the prompt statement we look at is something like this. So, what does it say? Suppose you'll be given some 2D array. In that, you'll also be given some source as well as the destination, and you need to fill that area which is being covered by this all ones with this value, with this new color which is 2. So let's try to understand this question a little bit more. So suppose we are given something like 111, then something like 110, and then we are 110. So now this is the starting location which is given to us. So it means that if this entire, I mean, the boundary which we are wanted to get covered is this all ones which is like there. So like with all ones, I mean this and this and this. So all of these things is the ones which we can color, but we'll see that which one comes into our region. So what initially we do is initially we make this as 2, and now we need to explore all the 4 directions of that. That is given in the question, that we have to go 4 dimensionally to those pixels. So we can make this as 2, and we can make this as 2, and after that we will starting at this point. Now again we explore all the 4 options, and this becomes 2, and this becomes 2. Next we explore is this 2, this 2 I'm talking about. Then I'm exploring this 2. So with this 2 will make below 2 as, sorry, the below 1 as 2, and yeah, so we are done. So this is the output which we are going to get finally. So one idea to implement this algorithm which we directly hit after even seeing the Wikipedia page is the DFS, because here also you see they are applying the DFS only. They started from one point and then they explored all the way to the down, then up, then this, and then they returned back again to this pixel, and then they continued and so on, right? So they continued like this way. So the one basic idea which comes to anyone's mind is the DFS idea. So everybody knows about the DFS, right? So DFS is something like this. What does it say is, for every vertex we initially say that their color is white. Color is white means they have not been visited. So, and their previous is none. And then for every vertex we check if the vertex is not visited, then we do a DFS over to the entire call. So that's the basic pseudocode of the DFS, but how to apply it in the question is something sometimes it becomes very tricky. So how we can apply so that this question becomes accepted? So it's very simple. So one thing is, we first go back to the initial stage from where the question was. So yeah, so the source and the source row and the source column is given as this. So initially we check if this location is 2, we are done. We don't need to do anything, because if it is 2, we don't need to explore any other options, and we are done. So we first did the same thing. We try if image of the source of this is equal to this new color. If that is the case, then that case will return this image which we are getting. If that is true, will return this entire thing and we are done. Otherwise, we know that we need to call the DFS function. Inside the DFS function, we know that we need to give this uh, source row, source column, this image which is there, and this new color which is there, and the current color of the pixel, which is in this case is 1. So current color we also need to pass, and the current color we can only get by doing this. And what we're going to do is we are going to pass this image as a reference. So whatever modifications is going to be done is going to be done in the original 2D array. So finally we'll return this image, and now we'll write the DFS function. So the DFS function would be direct. So just accepting the parameters which are there. So this, and we need to get the new color, comma old color. So now what we need to do, we need to first make this color, like in this case we need to first make this one as 2. So we are doing the same thing here. We are just going to make this color as the new color first, and then we need to explore all the 4 directions which is reachable from this. So for that we are just saying we can go to the one row below to that. I mean, from this we can from this we can go up, and we can remain in the same column, and we need to pass this image, and we have to pass this new color, and we need to pass this old color as well. Now other option which we are having is, okay, so the other option which we are having is, instead of going up, we can go down as well. And the other option is we can go one column back as well, and or we can go one column as, like one column one forward as well, and yeah, so these things. But the issue here is, if we are at like standing at this position, if we try to go up, then we'll go out of this 2D array. We'll go out of this 2D array, and it will give me the segmentation fault. Similarly, if we are standing at this location, and if we try to go right of it or up of it, then it will give me the segmentation fault. So we just need to handle that, and we are done. So we'll just say if SR is less than 0, or SR is more than equal to image dot size, which is the number of rows, or SC is less than 0, or SC is more this SC is more than equal to this image of 0 dot size, or the other last thing which I'm going to tell you is, if some location is already being traversed, it means if it has already been like processed, so in that case we need to return back. So we will just say if image at source comma column, if that is not equal to the old color which has been passed, then in all of these cases we need to simply return back. So that's it. So we'll try to submit it and find how many errors we got. So yeah, now if we try to submit it, yeah, it's accepted. Of course it should get accepted, man. Yeah, so this is one thing which is called as the flood fill algorithm. So, like from this question, what we can actually learn is that in any question which is related to the concept of DFS or DFS, mostly what we need to do is we need to like we know the DFS algorithm, but we're not able to apply just because we have not done enough questions. So I think this question will basically explain how we have to apply the DFS and how exactly we need to think from scratch. Like in this question, we started with some base case, and then we said that we need to just make that color as a new color, and then we need to explore all the four ways which are reachable from it, and we are done. So these things we should easily understand. And there is I can do one more question, which is nothing but again a very famous question called as the number of island problem. See, this is entirely based on the flood fill algorithm. If you know flood fill, you can do the number of islands as well. So if you understood the flood fill, you can directly try to do the number of islands problem one, and then see the answer of this question. So in this question, if you see, we have this 2D boundary matrix. In this, one basically denotes the land and zero basically denotes the water. So what we need to do is we know that what is an island. Island is an area which is consisting of land and covered by everywhere from the water. So if we go to island, and we know that island looks something like this, right? Yeah. So this is one island which is covered by from all the ways to the water. So this is exactly is our question. So you'll be given some water and land combination, and you need to just count the number of islands which is there. So for one example, I'll explain. Let's copy. So in this we can directly see that this is the island which is I think if you see this entire portion is one island, because in this entire portion if you see everywhere it is going to be covered by water. Now we can easily assume that in the above area, like where my cursor is, so in this above area and to the left of it, we are having the water only. So in the top of it and towards the left of this entire matrix, we are having the water only. So I think example 2 would make more sense. So if we see this example, uh, so in this example, we can easily see that this is one island. See here, this is this above 2 and this below 2. So these will make one island. Now this will make another island, because if you see up, down, left, right, everything is covered with water. Now you can see this is one more island, because if you see the above, it is water. If you see the left, it is water. Down and right, everything is water. So there are number of islands in this example is 3, and in this example it is 1. So we need to just return the number of islands. So now you must have understood the thought one approach, that is uh, we will just traverse this matrix, and then as soon as we get any one, so from this one we need to find uh, we need to go in all the four directions which are possible, and we need to make, if that direction consisting of one, we need to make it as zero, so that we include it into our island. And then I mean, as soon as we have covered all the ones from that location, we'll say that the number of islands has been incremented by one. So let's try run this here. So what I'm saying is we started from this side. You said, okay, so this is zero. It means I've seen this. Now after this first zero, I go to the left. I said, okay, so this is zero now. Now for this zero, I traverse all the four directions and I go down and I make this as zero. Now I go back, and for this zero, let's make it a bigger one. Wait. now it would be very clear if we, because writing code for this question is pretty straight. Okay, so see here. So what we are exactly doing is, so just make other color. So what exactly we are doing is, we started from this one. We make this as 0. Now with this 0, we will go to the right of it, and we will make this as 0 because we have seen it and it is a part of one island only. And then after seeing this from this 0, we see all the four directions which are possible. Now we go down and we make this as 0. Now we return back, and then we return back to the starting this 1. Now with this one we go down and we make this as 0. Now we are done. So we have got number of islands as 1. Okay, so the number of island now is 1. So I can just mark something like this. So this will become our one island. Okay, so this is our one island. Now similarly we will go like we'll now try to find the another location of 1. So the another location of 1 will eventually comes out to be this one. We'll make it as 0. We try to go up, down, left and right, but everything is 0. So we will just make this as the another island. So another island is going to be this one. Now we will just explore this one, and these last two will also become the these last two will again become these last two ones will again become one island. So the number of island in this problem is 3. Now we'll write the code for it. So okay, so we need to first reverse the matrix. So we'll say for I equal to 0, I is less than this grid dot size. Now we go towards all the column, which is j is equal to 0, j is lesser than grid of 0 dot size. Now what we need to check is we need to just pass on to one DFS function and do the same. So we'll just say if that location of grid of I comma j is equal to 1. In that case, what we need to do is we need to implement the number of islands plus plus, and we need to call the DFS function from that location. So in the DFS function, we just need to pass the grid comma I comma j. So after this entire function is going to be done, return this value of this number of islands. Now we need to write just the this DFS function. We need to just write. So let's start to write this DFS function. In the DFS function, we said we will get this grid, and we'll get some int I. comma int of j. Now, like the previous year, like the previous question, we need to see that if we go out of the boundaries, or at that location we have already got 0. One thing is we are getting this correct. Like this is not an integer matrix, so we can just use it in boards and it will work. If that is the case, in that case, we need to, if all of these things is fine, I mean, if these things occur, we need to just return like the previous question, and now we can just make this grid of I comma j as 0 and explore four options that we are done. So we just say DFS of I plus 1 versus grid comma I plus 1 comma j. Just make this as I minus 1. Other option could be to make this as j plus 1 or to make this as j minus 1, and we are done. So let's try to submit it. Okay, so we have not declared this number of islands. So we'll declare here. We are getting 9. Why? Okay, let's see again. So we are going and seeing all the columns, and if the value comes out to be 1, we are incrementing it and passing it to grid function, and inside this grid function we will just like checking if that is this all of these things happens, if I is exceeding this grid dot size, or j yeah, so j is exceeding this grid value, then we do this. Yes, now it is accepted. We can try for other option, but let's try to submit and check in what cases we are getting failed. So we are getting some runtime error for some input. Okay, I think if we are getting some runtime error, it means there is some error here only. So j is this, I is this, j is grid of size for this, or this is equal to this. In that case, return. Otherwise, this, and then we do I plus 1, then we do I plus 1, we do I comma j plus 1 comma j minus 1. Okay, and here we are getting mistaken. Okay, let's see how many test cases are passed. So only one is passed. Okay, This is also fine. Okay. Okay, testing again. Really fast. So yeah, right. We are getting lost. Some small mistake is probably there. Check. Okay, we are including all the columns of this, and then we are checking if that location is equal to 1. In that case, we are just doing number of island clusters and try to okay, try. See, but we're getting lost. Okay, so do one thing. If we do something like see, I don't know why this segmentation fault. It is either taking it as a string or what. I think there is some problem with this. Let's see what we are missing. CRI separate solution. Some small mistake I think I'm doing. Okay. this, doing this, doing this, doing this. Okay, do one thing. I think what we can be wrong is we can just the only thing which comes to my mind now is this. I don't know, man. What it is happening. Oh, yeah. So the only thing is there is nothing need of all this. So what I was missing is this one thing. Let's take this code in which we got the runtime error and try to see. We was just missing one small thing. So we'll try to edit this code. I was just missing this small thing that since the indices start from 0, so it should be if I is matches to the grid size, then in that case we have to return back. So this was a very small thing, but it is tried. So now try to submit. Yes, it got accepted. Okay. Yeah. Okay. Thank you.